Hurry, I'm gonna continue about a little bit about what he said, but it's just a little more cool. It does a lot of face recognition, all the electronic softwares. It's just not a hand. That's what I'm saying. So there's this company called 3 Detection in Moscow. So they pretty much there's not much information about how many people they have or anything like that. They're pretty conserved. They have a lot of things in Russian, so I can't understand. Yeah. So the most of the things they do are surveillance systems, 3D scanners, biometric security systems, facial recognition, and all that. And they do a lot of robotic, like try to do humanoid robots and all that things. So this was one of their robots which they did. So it's pretty much like a robot which you can come home and ask it to do whatever you want to do. And most of their mechanical components, like like I meant, the things here, the multi-stage manipulators, the platforms, wheel reductions, and drive systems, most of them are created using 3D printing. They actually started out as using it just as prototypes to check if they can do it, but then once they start doing it, it seemed to be more economical, and at the same time, it was much more better than the actual parts they created using traditional manufacturing. So they was like, okay, we can just stick to this. They used the ABS material, and then they were using the Dimension 3D FDM printer. So they started out with the robot forearms, the neck reduction gear, which and rotation gears and neck swinging mechanisms and all that. The main things was that they had a lot of designs for it to actually work because they have a lot of internal structure in theirs. Like they have to have a lot of semiconductors and a lot of PCB boards and everything for them to work with their electrical components. So they had a lot of problems when fixing their mechanical drive systems and stuff like that because they had to make sure it can accommodate that and this. So they need to have some designs which were discrete and not usually common. So 3D printing was something which helped them to do prototyping at the same time use it in the real life robot which they actually built as well. And the other thing was it was more precise and durable, the parts which they produced. So the next one is a training module by the US. It was done by Golden West Humanitarian Foundation, but it was actually the US Department's post-war weapon removal and training programs kind of thing. So what they do is they pretty much provide war relief. They provide training to all specialists in for them to be comfortable. I mean, not comfortable, familiarized with the different components they have in different grenades or landmines and stuff like that. So that when they actually identify it, they be able to dispose of it much easily. This was one of their landmine fuse assembly which they did. I don't know what material they actually used to do it, but they just used FDM. They had different kinds of color codes, and they were able to do it was actually the landmine. The fuse assembly is very small in the landmine, so it's not usually easy for specialists or anyone in that and in the situation with the stress and amount to actually find out every single component and identify and then do it unless and until they've actually had a lot of training and they are pretty much familiar with the whole fuse assembly and stuff like that. So they used additive manufacturing to actually make a large scale and a larger scale fuse assembly of the same thing, and the fuse assembly in the actual landmines and the one they created usually have color codes so that it's easier for people when they're assembling at the same time. Like for these people here, that's kind of like an advantage here. So they did pretty much the same replica but then a larger scale so that it'll be easier for them to do it. And this is not the only thing they've done. They've done a lot of other things as well, like similar kind of things, but like for pistols or weaponry in order for them to actually no, this is not. They're not telling how to put one. So they're saying like most of the time when a war happens and they go off and a war ends, people do not actually remove all the weapons and go off. So there's a lot of chances that the locals who occupy that place actually step on a landmine and they die. So there's a lot of instances like that which has happened. So in order for that not to happen, this is like a global organization who create these training programs along with the US Department of Weapon Removal and stuff, so that they'll be able to help people to actually identify if there's something and how to dispose of it if they've actually stepped on it or something. So it's kind of like this, so that people will be able to identify what it is. They can make the assembly at the same time they know how to disassemble it as well. So they have different part. So this is the actuator which actually actuates when you press on it. So they have different power. They have different color codes in order for them to identify the different parts inside, and be sure which one to press and which one not to press in the situation. I mean, naturally, you don't want to, you don't want to, it's not something you can play with. They take it out, okay, this one looks cool, we can just press that. No. It's called the Explosive Ordnance Disposal Training. So they used it for specialists and stuff. It's cost effective, and they they had multi-material FDMs with dual extruders and stuff, so that they were able to create multi-material, multicolored products at just one time. So it's much easier rather than actually casting each one separately, making it stuff like that. And they were able to scale up the small fuses into larger scale replicas very easily rather than designing it again. And they had good quality, and the mechanisms were working properly as how it's supposed to work. So these are my references.